Welcome, and thank you for tuning in to Organo Living Silica's webinar. Today, we will be talking about silica and its many benefits. Stay tuned and learn a thing or two. Now, let's get started. So you're probably wondering, what is silicon? Sounds familiar, right? Well, the base element is silicon on the table of elements we all remember being taught in chemistry in junior high and high school. It's primarily going to be quartz if it's a mineral type. It's also available in other stones just as jasper, mica, and zeolite, just to name a few. It is the second most abundant element in the Earth's crust next to oxygen. In our bodies, when we're born, we tend to have 7 grams of silicon present, which is important to be aware of. I do want to mention, we talk about silica and silicon. Silica is actually the term used to refer to a combination of silicon plus oxygen. That is what's going to make it assimilable by our bodies. Silica is also the term used to indicate dietary sources of silicon. For example, what our bodies are able to digest, absorb, identify as nutrients. When we say X part of our bodies use silicon, we refer to silicon extracted from silica. The terms may be used interchangeably when we refer to the dietary form of silicon and not in edible forms. The next few studies I'll touch on will be on sex, or gender to be quite exact, which will be abstracts and quotes. Gonk and School, quoted by Desmonte in 1988, observed 35% less silicon content in muscular tissue in females compared to those of males. That would make sense, of course, since males tend to have much more muscle mass than females. But there's another point. That it's important to know that silicon is not only in our bones and other parts of the body, but it's also in our muscular tissue. Now, when we speak about silicon in relation to age, Monclaw, quoted by Desmonte in 1988, observed a general decline in silicon levels with age. For example, silicon content in the integumentary system decreases by 30% in older age groups compared to those of a younger age group. That's just mentioning one part of our body, though it declines in all parts of the body, particularly in middle age. Intestinal absorption of silica also decreases with age. In regards to pathologies, in the aortic wall, silicon content is 4 times higher in children than that in adults. Silica content in the aorta, the thymus, and the skin in humans also decreases with age. These are very important to know as we experience the changes from youth to middle age to elder age. We notice these changes in our bodies that occur very gradually, and in this respect, regarding silica, we need to know that the quantity of it decreases, which is why we need to supplement it. So as mentioned previously, we had the issue with males having more silica than females due to the muscle mass. Now we have the issue where estrogen levels decrease in women with age and the absorption of silicon reduces simultaneously. This explains the tendency toward decalcification of the bones. At the beginning of this decalcification process, silicon concentration in tissues dramatically decreases up to 50% compared to minerals such as calcium or sulfur, which only decrease 5 to 8%. So it's not a case of all the minerals declining at a gradual rate. It's more so the silica in general in the bone. And this is why you see it particularly affects women more than men. Although men, of course, do also contract osteoporosis. Silicon levels do decrease about 1% every year with aging. Silicon loss is more intense from the ages of 35-40 years onwards. It can be later, it can be sooner, depending on the body, depending on genetics, depending on the use of the body as well. Interesting enough, teenagers have 400% more silicon than seniors ages 70 to 80 years. Silica diminishment does lead to reduced collagen production and many other molecules. Not only do the silica levels decrease with the body, the absorption of silica we normally would take in through dietary intake, the absorption levels also decline. So we actually have to take in more silica to achieve a similar level we would have had years before. Now, silica in relation to the metabolism. Our bodies do not accumulate large amounts of silicon, but do require a permanent intake. It has a direct influence on absorption of specific minerals required to maintain health. It is considered a catalyst, accelerates the absorption of calcium, magnesium, iron, and phosphorus. All of these are critical for new bone creation. Without silica, the connective tissue has an inability to retain moisture, which is what allows for flexibility. Connective tissue consists of collagen, elastin, mucopolysaccharides, and mucus carbohydrates. Silica in itself, while it has numerous benefits, the catalyst for other body mechanisms, it also works as how all other minerals are absorbed. Here we see calcium, magnesium, iron, and phosphorus. All are critical for new bone creation. As we will see, silica is integral in creating new bone. Without silica, we are unable to retain moisture in our connective tissues, aka the flexibility, the ability to bend, to grasp, to move quickly, our hips, our knees, and whatnot, and also to produce collagen and elastin, which also, as we will see, is critical in terms of anti-aging, photoaging of the skin as we get older. Now we are going to spend a bit of time showing how silica is needed for bone. Silica is needed for calcium to be properly absorbed. Silica, in conjunction with other minerals such as phosphorus, boron, magnesium, etc., aids in bone growth, strength, flexibility, and density. Here we see an example where too much silica, but not enough calcium, our bones bend easily, it's elastic, whereas a bone that has too much calcium but not enough silica becomes brittle, it shatters easily. It's a balance. It's fascinating how our bodies are a total complete balance, where we require a balance of minerals and nutrients in our bodies in order to grow and stay healthy. Silica also enables bones to be more elastic, and combined with calcium makes bones thicker, which is why when we're younger, we have the ability to survive impacts such as jumping off trees, jumping from high elevations. It's much easier than when we're older. When we're older, our bones are thicker, they're more elastic. It may not make much sense how thicker bones are more elastic, but it's because they have more tensile strength, and that's what the silica with the other minerals are able to do. One thing to be aware of is silica deficiency results in malformed or weak bones. Today, it's very much a case where calcium is prescribed to be used for bone health, but actually when it should be silica. Most people get enough calcium through their dietary intake, but as you should see, doesn't happen with the silica. The other issue, of course, deals with what we refer to as osteoporosis. Increasing calcium intake alone without the silica actually accelerates the leaching process of existing calcium within bones, and bones constantly replenish. So we have the body unable to properly absorb calcium. It will still continue creating new bone, but that bone, as we see here, will be more porous compared to a denser, healthier bone, one which would have all the minerals properly absorbed. Here we see bone health following a fracture. Here's when silica is very critical. We always say within the first 30-day cycle. Here's those 35 days. However, within that first 30-day cycle is when a much larger silica intake than usual is required for fracture. Silica helps a great deal with after the inflammation period, which is, as you see here, days 0 to 5. Days 5 through 16, the fibroblast, the osteoblast, that's all new bone being formed and leads to the previous slide. If the body is not properly using the nutrients it needs, the minerals that it needs, which silica is a balancer, sort of speak, which enables good absorption, the bone will not heal as quickly as it normally would, and that's why it's critical for that formation. In regards to silica in the skin, we were talking about collagen earlier, and that's one of the main benefits we're going to speak of here. Collagen is the main protein of the body. Silica activates the enzyme prolyl hydroxidase that boosts collagen reticulation, in other words, strength. It's not the elasticity of our skin, but more so the structure of our skin. It's been shown repeatedly that the higher the silica content of collagen, the more structure there is on each of the fibers. In other words, there's more girdles and supporting tensils. It's almost like a bridge network, like a ladder. Silica is also integral in the production of elastin. Elastin is what makes our skin elasticity. Elastin works with collagen and is also silicon rich. As we age, these levels naturally decrease. It's part of the aging process. What we can do, of course, is increase our supplementation, which is the process we're after to enable the body to maximize possible production of collagen, elastin, and that's why silica supplementation is critical. Glycosaminoglycans, these provide strength and structure to the skin's tissues. Skin is a very complex matrix. It has several layers. As we see here, it includes the collagen, it includes the glycosaminoglycans, a gel-like matrix. It includes moisture. The silica is able to provide moisture to the cells as they build collagen fibers, as they build elastin, so that it maintains that measure of youth. As it produces, it enables the body to maximize its natural production. Let's take a quick recap of what we just saw and viewed. Skin tissue is silica-rich when we're young and depletes as we age. The most effective manner to boost collagen levels is to boost silica levels. We saw how taking collagen supplements alone is not sufficient enough to guarantee an increase in existing collagen levels. The effects of using silica are more pronounced than by only consuming collagen. Silica provides the natural pathway for collagen creation. Silica has a long history of it being used for wound repair. Previously, it was prescription grade only. Now it's over the counter. Those, however, are chemical silica. They have several chemicals inside. What we here at Silicium Laboratories recommend, of course, is natural silica, which do not contain any chemical composition which our bodies do not need. As we were referring to, silicon in itself is essential for the new matrices of collagen and elastin fibroblasts, in which are accelerated when the skin is rich in silica. Our joints, the articulating or mechanical aspects of our musculoskeletal system, are moved by collagen fibers analogous to interwoven strands of a rope forming basically the means to push, pull, turn, rotate weights. As we see here, ligaments bind bone to bone and tendons bind bone to muscle. Both are primarily 90% composed of collagen, which is, as mentioned before, the main protein found in connective tissue. So we have again, when we're young and healthy, the joints are silica rich, and as we age, it naturally depletes. Injury, overloading, poor diet, and of course aging leads to collagen degradation, which in body mechanics is manifested as limited mobility or load-bearing ability, such as difficulty in bending down. Our joints become stiff. We are unable to carry as much weight as we used to, and or it can lead to worse, such as tendonitis, inflamed ligaments, etc. Our goal is to change that. Of course, referring to cartilage, we show ligaments and tendons, the kneecap, the spinal discs, that of course is cartilage. In this case, it is also a form of collagen. Cartilage is a rigid form of collagen. Cartilage is a type of connective tissue comprised of a matrix of protein, collagen, sugar, and chondrocytes. 50% of its dry weight is collagen, which is a flexible and strength component. As mentioned prior, decreases in collagen may lead to limited mobility or injuries caused everyday movement or vulnerability in sports and recreational activities. As we're learning, silica supplementation increases collagen, thereby offsetting decline in collagen levels, and is either a proactive or reactive factor in maintaining a healthy cartilage. I'm sorry to sound repetitive, however, it's important to show just how important silica supplementation is in improving overall body mechanics. Interesting enough, when we're referring to brain health, aluminum deposits, aluminum is a neurotoxin, as we see here, on which aluminum exposure creates neurofibrillary tangles, so to speak, the same twisted proteins found in brain cells when we refer to patients with Alzheimer's disease. Silica, uniquely enough, binds with aluminum to extract it from the body. Our bodies have antitoxin processes through aluminum is able to bypass them entirely. Unfortunately, it forms deposits in the brain and therefore decreases cognitive function. This is where silica is essential for brain health. Silica molecules bind with aluminum and enable the elimination of deposits from the brain through toxic waste. Research conducted by Alzheimer's disease specialist Dr. Chris Exley of the UK demonstrated a 70% reduction in aluminum after a short interval of silica supplementation. Research also demonstrated a direct link between aluminum and the body and the propensity for Alzheimer's disease to occur. What we can draw here, based on the studies, is that silica breaks the aluminum to Alzheimer's connection by removing the aluminum. Now you may ask yourself, how does it do that? Well, as you see in the illustration shown, this is a nerve synapse, which is the process by which a nerve transmits a signal to another nerve, and silica just so happens to help improve the nerve synapse. The nerve synapse is basically what can command to move your fingers. It can be a memory recollection. It can be an involuntary process like the lungs breathing. These develop plaque on the ends, as we saw in the previous slides, showing the MRI, which blocks a signal or slows the signal from processing over. By using the silica and bonding with aluminum, removing the aluminum, we're basically able to unplaque the deposits on nerve endings, allowing for signals to transmit clearly and much quicker. Now we step into silica and the cardiovascular system. As we begin to speak about silica and the aorta is healthy and rich in silica when we're young. Silica assures the elastic integrity of the aorta, leading to resilience in cases of increased blood pressure. The decline of silica with aging results in vulnerability to plaque buildup in the aorta, plus also weakening this critical pathway, leading to a higher risk in cardiac issues. So if we supplement with the right type of silica, again, the body sends the silica where it's needed. We want to supplement so that the aortic wall is as healthy as possible throughout our lifetime. In regards to silica and the immune system, the lymph nodes hold the body's highest silica content, about 45%. They are responsible for producing antibodies, including those that identify themselves as invader cells. Due to the fact that we want to maintain the highest silica content in our lymph nodes as well. High silica intake also leads to less swelling, as this is also controlled by the lymphatic system as well. So it comes down, as we've seen all the numerous benefits. Very briefly, what types of silica shall we use? Well, let's go the natural approach. Principal sources of dietary silicon are whole grains, fruits, beverages, and vegetables in that order. As we see here on this graph, we have beer, red wine, assorted greens, cereals. You have the silica content right here. How much silica do you primarily need? Well, we'll get into that in a bit. You might think, well, I can simply eat some cereal and get enough silica content that way. It doesn't exactly work that way. The issue stems down to the bioavailability of silicon for intestinal absorption depends on the solubility of the silicon compound. Just because, as we see here, beer holds 8.25 milligrams of silica doesn't exactly mean the body is going to assimilate that to being something we potentially need as food. See, smaller molecules or monomeric forms are better absorbed than larger chains or polymerized silica forms. So in the past, we were used to having diets with 10 times more silicon, and only 2-3% of silica consumed from foodstuff is actually absorbed. The reasons of this decreasing rate of silicon are as follows. The aggressive horticultural methods and chemicals being used today burn the microorganisms in the soil that solubilize the inorganic silicon. Consequently, both the soil and vegetables plus animals have a much less amount of silicon for us to consume. Not to mention, the 21st century diet often differs than that from the ideal, with refined foods instead of enough raw veggies, seeds, roots, leaves, and fruits. In general, according to the USDA statistics, more than 96% of Americans are not getting adequate intakes of micronutrients from food alone. That's based on the government's average requirement standard. That's a big percentage. With approximately 317 million people in the United States alone, this basically means that there are more than 304 million men, women, and children suffering from a micronutrient deficiency of some kind right now. That's crazy just to think about. A little scary if you ask me. Now, referencing on the recommended silica intake, as of now, there is no RDA for silicon for the U.S. Department of Agriculture. Researchers who specialize in silica indicate up to 50 milligrams is needed, however, for European and North American populations. This might be the most important slide to discuss and point of view to selecting the right type of silica to supplement. We now discuss the historic issue with silicon. Russian researcher Voronkov, who is an organic chemist researching for 50 years, said, these compounds are insoluble or produced in contact with gastric juice, an insoluble silicon. In other words, silica is an oxidized form of silica which becomes bioavailable and can enter the metabolic circuit. Though breaking the molecular bond, silicon and oxygen, involves a very strong link, as you see demonstrated in the formula below. In other words, our body needs to absorb a silicon plus an oxygen molecule. Silica, in other words, but it requires 200 kilocalories. That's an energy term, which is equivalent to 200,000 calories. Our bodies are simply not able to break it down, which is why most silicas are not properly absorbed by the body. And that is the issue when we come across questionable, cheap silicas in bulk raw form that are extracted from plants and whatnot, that the body cannot break down sufficient silica to be useful for the body. Simply, the human body is unable to break this link. When it detects an oxidized silicon, it is considered a pollutant, as otherwise previously mentioned, an invader of sorts, and therefore having the body expel it. This allows us to better understand the importance of the discovery of the molecular forms of non-oxidized silicon, organic and soluble forms. Silica is also available in some nutritional supplements with varying amounts of bioavailability as previously discussed. In general, as we know now, the smaller molecules or monomeric forms are better absorbed than the larger, highly polymerized or oligomeric forms. This here is an independent research study done in 2007, which demonstrates the comparative absorptions of silica from different foods and food supplements. So what this means is, when you're selecting silica, dietary sources such as the beer, the raisins, the grains are very minimal forms of silica. Your body will expel what it does not see as a nutrient. It will treat it as a toxic, therefore eliminating it as waste. When you're shopping for silica milligrams is not an indicator of benefit. It is the higher grade silicas from proven sources that should be the most beneficial. Of course, those that have the research and specialize in it.